Section 9.2 is on graphing and writing equations of parabolas. Now you've dealt with parabolas that open up or down, and now we're going to deal with parabolas that also open to the left or to the right. So there's a lot more properties involved. So first let's start with a parabola that opens up. Here's my parabola, and we're going to list the different properties of them. First off is the axis of symmetry, which I've already put in here. The axis of symmetry is where you can fold your parabola in half and all the points on both sides would line up with each other. So this would be the axis of symmetry here, because we could fold this in half and it will line up. And now I'm going to kind of label two things simultaneously. There's a point on your axis of symmetry called a focus. Focus lies on the axis of symmetry. And with that, there is a line that's on the other side of your parabola called a directrix. And this is perpendicular, and I'm just going to make the sign for perpendicular to the axis of symmetry. Perpendicular meaning it has to be 90 degrees. Now this directrix and the focus are equidistant away from the vertex. So it's equal distance from the vertex down to the directrix and up to the focus. And actually any point you choose, if I would choose this point or this point, it is equal distance from the focus to the directrix. So this length and this length would be the same. Or if I choose this point, this length and this length would be the same. That's kind of how the focus and directrix work together. So those are the properties of parabolas. Okay, now I said our parabola could open up 4 different ways, so I'm going to label 4 different pictures for you. So first off, what we just did, a parabola opening up. We know we have a focus here, and it's at the point 0 something, 0p. This is our vertex, and it is at the point 0, 0. And we have a directrix, a line opposite the focus that's equal distance, and this is at y equals some negative p. So whatever this number is, we just make it negative, and that's the directrix. And the equation for this parabola is going to be x squared equals 4py, and p is greater than 0. We're going to be dealing with this equation later, so it might not make a whole lot of sense right now. So let's label the other pictures. So here, if we open down, our focus is always in the inside of the parabola. So this would be our focus at 0p, whatever point that is. So then that means that our directrix is on the other side, equal distance, and we just flip the sign so we make it negative. So this would be y equals negative p. And then your vertex again is just 0, 0. All the parabolas that we're going to deal with have a vertex of 0, 0 for this section. And the equation is going to be x squared equals 4py. Nothing changed there, except in this case our p is less than 0 because our focus is below the x-axis. So now let's go left to right. Again, the focus is on the inside. And now we're at some point p 0, because now our y is 0. Directrix is on the other side. At x equals negative p, because now we have a vertical line, so now it's x equals negative p. And the vertex is still 0, 0. So now the equation for these lines is going to be y squared equals 4px, and our p is greater than 0 because it's positive. So that would mean that here's our focus for this one, inside of the parabola at some p0, meaning our directrix is on the other side. At x equals negative p, and our vertex again is at 0, 0. So then our equation for something that opens this direction is the same, y squared equals 4px, and now our p is less than 0. So let's apply all these properties so that they make a little sense. First off, here is mainly what you're going to need. This is exactly what I wrote down except without the pictures. So we have two different equations. If it opens up or down, you're going to be using this first equation. So this is if it opens up or down, and this would be left or right. And these are the properties I just wrote down up there, a little bit more simplistic. So let's practice graphing one. Your first step in graphing this, and then we have to identify all these pieces, is to get this squared term by itself. So we need to solve for y squared, so I'm going to multiply by a negative 8 to solve for y squared. So my equation is negative 8x, these cancel, equals y squared. Because this is in the form, if you scroll up, this second equation right here, y squared equals 4px. I know that I'm using this form, y squared equals 4px, because I have a y squared. So if you want to flip this around, if that helps, you can. Because now we can find all of our pieces. Let's start with our focus. I know that the equation, I have a 4p times x. So that means right here, this is 4p, because I have a number x, so this is 4p. So think about, what did you have to take times 4 to get negative 8? Well, I had to take 4 times negative 2 to get this negative 8. So that means that p has to be negative 2. So if I start my graph, and everything you need is in this little chart I gave you. You know that we're using this equation, so our focus is going to be p comma 0. So my focus is going to be negative 2 comma 0. So I go over to negative 2 comma 0, and so my focus is right here. So then the directrix is just this number, change your sign. So my directrix is positive 2, 0, and my directrix is a line. So my directrix is the line x equals 2 right here. So then to get some points on this graph, I know it's going to be opening this way because my focus has to be on the inside, and the directrix is on always the bottom of the parabola. So it's going to be going like this, opening up to the left. So I need some points to graph this. The only point I know is the vertex. I know the vertex of my parabola is going to be right there. But I need some other points, so I'm going to make a quick t-chart. And when I pick my x values, I obviously can't pick anything over here, so I'm going to go with negative numbers. So I'm going to pick like negative 1, negative 3, and negative 5. So when I plug those in for x right here, you can actually plug it into either equation. This one's probably going to be the easiest. So when I plug negative 1 in for x, and negative 3, this is positive 8, and then to get rid of the squared, you take the square root of it. And remember, when you take the square root of something, so we'll have, I'll kind of go this way, I'm running out of room, y squared equals 8. When I'm solving an equation and take the square root, I have y equals plus or minus, and we get about 2.83. So that means at -1, I have the points positive and negative about 2.8. So like right here and right here. So when I do -3, I should get about plus or minus 4.9. And 5, I get about plus or minus 6.3. So I have -3, about 4.9. And 4.9. And then I'm going to run out of room going up here. But it's about there. So when you go to make your parabola, it's going to look something like this, except better than mine, because I'm a little squiggly here. This should not be a point. This is supposed to be a curve. My graph is just a little smushed. But that should be the parabola opening up like that. So the only thing we haven't labeled, that's a really sad graph, is the axis of symmetry. So our axis of symmetry is where can we fold it in half? Well, it's this line right here, so it's the x-axis. So our axis of symmetry would be at y equals 0. That's the x-axis. So we've labeled all of our points. The other thing you're going to do is you're going to get a picture of a graph and you have to write the equation. And these are a lot simpler. First, you have to find out which type of equation you're using. So if our graph is opening up, if you go back up above, I'll scroll up quickly. You see, if we open up, we use this equation. And I also have it here, if you open up or down, you use this equation. So we're going to be using the equation x squared equals 4py. And think about, we've dealt before with things that open up or down, and they used x squared. So maybe if you think of that, you've been using x squared and that opens up or down. And then we just fill it in. The only thing we really need is p to make this equation. If you look at your directrix is at -1.5. So -3/2. If you remember, the focus is the same number just flipped on the other side. So that means our p is right up here, and our p instead of -3/2 is a +3/2. So you just fill that into the equation. So x squared equals 4 times 3/2 y, and then simplify, and your equation is 6y. And that's it. So those are pretty simple. So I want you to go ahead and try graphing one on your own. First step is to solve for the squared term. So you want to get this all by itself, so you're going to multiply by -4 on both sides. So your equation is x squared equals -4y. Okay, so we have your equation. And then it's easiest to find these in this order. I would go with the focus first, then find the directrix, and then get your points. You'll have to make a little XY table, and you can just use 3 points, and then your axis of symmetry last.